Hi. When using any TI device, it is necessary to follow the information in the datasheet, which you can download on ti.com. It could be challenging to follow the information on the datasheet, but in this video I will show you how quickly you can verify the information on one of the FPD-Link devices as an example. I will go ahead and show you on the slides. All FPD-Link data sheets include a recommended Powerup sequence. The Powerup sequence ensures that the circuit blocks are enabled in the expected sequence inside the device. TI characterizes the FPD-Link device with a datasheet-defined Powerup sequence. This is done to ensure proper operation for the device. Also, it is done to avoid any random behavior that can result from operating the device beyond the datasheet spec. Please note that this differs from one device to another because some devices have different tolerance to noise or application conditions than other devices. As you can see, this is the Powerup sequence diagram for the DS90UB926. Your VDD-IO powers up first, and then after 100 microseconds, your VDD-33 powers up next. Once both VDDs are settled, your PDB powers up, which enables your device, and your device starts operating. In this slide, I will go over some of the issues that you might encounter if you use the incorrect Powerup sequence that's not defined in the datasheet. Some of these issues may be the blanking or the flickering screen. Also, you might encounter I2C communication issue, which could be remote or local to the device. Make sure to follow the Powerup sequence that's defined in the datasheet to ensure proper operation for the device. Now that we went over some of the issues on the system and device level that may be encountered when using the incorrect Powerup sequence, I will specifically go over the datasheet specification for the Powerup sequence for the DS90UB926 to cover an example for Powerup sequence from the FPD-Link family. Here is how the section looks like for the Powerup sequence of this device. It can break down how you power up your device, whether you can power the VDDs separately or you can power them tied together. It will give you the specific components that you can use to ensure proper operation. Now I'll show you a demonstration on how to capture the Powerup sequence on your system. In this demonstration, I'm using 2 power supplies and the oscilloscope, also a TI EVM to capture the Powerup sequence. Once you have the equipment available, you can capture the VDD-IO, VDD-33, and PDB, and make sure they follow the Powerup sequence order in the datasheet. I'll go ahead and demonstrate how that's done on the oscilloscope. I'll single trigger and power the supplies. As you can see, your power rail are tied together, your VDDs, and they ramp up, and once they reach stability, your PDB starts ramping up. This is an example of powering the device in the incorrect sequence. As you can see, they start by powering the device with PDB and VDD-33, and then after they power the VDD-IO. This is the incorrect sequence because the VDDs are out of order and your PDB is powered first. The biggest issue here is powering your PDB first. When you power your PDB first, you enable your device, which means any voltage spike could damage your device. This slide shows another incorrect Powerup sequence. As you can see, they have both VDDs tied in together. However, the ramp time is incorrect. In the datasheet, it specified that ramp time should be faster than 1.5 millisecond. In this Powerup sequence, they have it longer, which means by the time VDDs reach stability, your PDB is already enabled. This can cause abnormal issues in your device and system level, so please follow the Powerup sequence provided in the datasheet. In summary, for all TI parts, it is necessary to follow the information in the datasheet, which you can download on ti.com. Thank you for watching this troubleshooting video on the FPD-Link device family.